In this video, I'll explain the concepts of factors and multiples in number theory. Now, as Rinchi mentioned in the previous video, problems involving number theory have been constantly popular in almost all types of mathematics competitions. However, number theory is not taught in the normal school mathematics curriculum in the depth required for the contest problem. Therefore, we'll discuss the topic in detail. Please keep in mind that every video will be presented in less than 10 minutes, so the concepts of factors and multiples will be further explained in the next few videos. Now let's get started by talking about the most basics of understanding the terms. So now we have composite number, which is a number that has more than two factors. A prime number is a number that has only one and itself as factors. A factor is a number multiplied by one or more numbers. A divisor is a number which completely divides the given number without leaving any remainder behind. And last but not least, a multiple is the product of that number. This leads us to the next section about prime factorization. What is prime factorization? Prime factorization is a method to find prime factors that will multiply together in order to make the original number. So here we have to remember to divide the given number by the smallest number until the quotient becomes 1. The smallest number is the prime factor. Let's say we need to find the prime factorization of 75. We can try to divide it by 3 first, because 3 is a prime number. Now, we know that 3 times 25 is equal to 75. 25 can be separated as 5 times 5, as we know that 5 is also a prime number. Then we simplify this as 3 times 5 times 5, and so this gives us 3 times 5 squared. Sometimes a question will ask you to find the number of divisors of a composite number. You can list out every divisor, but this will probably take a long time as the number is huge. So a better way to do this is to use this formula over here. So first we let n equal to a composite number. Then we will use this prime factorization of the number in the form of p1 to the power of a1 times p2 to the power of a2 times all the way to pk to the power of ak. And know that a1, a2, a3, all the way to ak, they're all exponents of such number n. Then we simply add 1 to each of the exponents of each prime factor. And don't forget the last step, which we have to multiply the new exponents together, and that will be the total number of divisor of a composite number. For instance, the question might ask you, how many positive factors does 5600 have? Pause the video and try to do it on your own first. So as mentioned above, we're trying to find the positive factors of such number n. So find the prime factorization of 5600 first. 5600, the last digit is 0, so we can first divide it by 2, and that is 2800. 2800 divided by 2 again, 1400 divided by 2 again, 700 divided by 2 again, 350 divided by 2 again, 175 divided by 5, since 5 is a prime number, which is 35 divided by 5 again, that is 7, and 7 can divide itself because 7 is a prime number, and that leaves us 1. So here, as you can see, these numbers on the left side, they're the prime factorized numbers that we need for this question. Now we recognize that there are 5 2s, 2 5s, and 1 7, so we can write this as 2 to the power of 5 times 5 to the power of 2 times 7 to the power of 1. And we notice that 5 to 1, they're all exponents of the composite numbers of 2, 5, and 7. And so here we can look at the formula on the right side, which is A1 equals 5, A2 equals 2, A3 equals 1. So put it into the formula, and that is 5 plus 1 times 2 plus 1 times 1 plus 1, 6 times 3 times 2. And that gives us 36 as the final answer of this problem. Getting a bit more complex now, we have the Euler's-Tauschen theorem. This tells us how many numbers are relatively prime to some number n. When two numbers have only 1 as their common factor, we call them as relatively prime. And this symbol over here is called a phi symbol. In number theory, the Greek letter phi is used as a symbol, especially for Euler's-Tauschen function. As you can see, this formula is similar to the previous formula, as phi n is equal to p1 to the power of a1 times p2 to the power of a2 times all the way to pk to the power of ak. This is the formula that we know as how many divisors, the number of divisors in a composite number n. But here we have to find the relatively prime numbers, as only 1 as a common factor. Because of time constraints, we won't go into detail of this theorem, but you have to remember the theorem's formula, which is n times 1 minus 1 over p1 times 1 minus 1 over p2 times all the way to 1 minus 1 over pk. Now p1, p2, all the way to pk, they're the numbers that have been prime factorized out, and a1, a2, all the way to ak are exponents of such number n. This will be useful as we go into detail of the problems below. Now take a look at this question. How many numbers from 1 to 72 inclusive are relatively prime to 72? Pause and think how we can apply the Euler's-Tauschen theorem to this question. Similar steps can be applied here. We can first figure out how it can be prime factorized. So 72 divided by 2 is equal to 36, divided by 2 again is 18, divided by 2 again is 9, divided by 3, that's 3, divided by 3 again, and that gives us 1. So, as you see on the right side, these numbers are the prime factorized numbers that we need in order to count as the phi of n. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3, which is equal to 2 to the power of 3 times 3 to the power of 2. So here we can see that P1 is equal to 2 and P2 is equal to 3. We don't have to worry about the exponents in this problem. And now we have to take phi of n. So phi of 72 is going to be 72 times 1 minus 1 over 2 times 1 minus 1 over 3, which is exactly what the formula says. And so this gives us 72 times 1/2 times 2 out of 3, and that gives us 24 numbers from 1 to 72 inclusive, which are relatively prime to 72. We'll stop here today. In today's video, we've covered the understanding of factors and multiples, how to do prime factorization, how to find the number of divisors in a composite number, and Euler's-Toten theorem. For next week's video, I'll explain several AMC 10 questions from previous years that will be directly related to factors and multiples. And it will be challenging, but I'm sure it will be easy once you master the concepts. Thanks for watching.